So a sculptor who makes a miniature statues has to make a cone out of what do you call it, a spherical object. So first of all, we know that we talk about a sphere. There is a ball like. So you cannot put it in 3D, but if I wanted to put it in 3D, we'll start projecting some uh, lines there in a curve. And I need the first stage of his work. Now, what is the height of the largest cone he can cut out from a sphere of a radius of 9 centimeters? So let me just put a dot there. We're at the center there. So we know that I need a color here. The color. So it has a radius of 9 centimeters, isn't it? A sphere. So it has a radius of 9 centimeters. So cut out a cone there. So it's just that we can't imagine this in. So don't have a practical thing. So let's say we had a sphere, it has to cut out this type of shape. So you need to draw that shape in there. So we're looking for the maximum height which can be cut out of the cone, out of the sphere. So we know that the other day we're dealing with a cone. We can draw it in many ways. So we know that a cone, it has its shape there. So I don't know how we can cut it, but let me mimic the picture that we have there. So let's say a cone has its own what? Its own diameter there. So let me say that it's a cycle, though I'm trying to draw it in a 3D. Now number two, it has its own radius. So I can drag out there the radius, so at least it must be to that point. Radius R. For that cone. Now we know according to cone, it has a perpendicular height. I wanted to use the blue one. So it has its perpendicular height, must touch one side, and then let's say to the tip. And other side to the tip. At least the cone came out. So let's say for an example, he has to cut out the type of similar cone. Drop it. So that perpendicular height must be from the base of the cycle to the apex. The base of the cycle of the cone to the apex. Normally we know that it forms a right angle triangle. It forms a right angle triangle. So we know that according to when I was looking at this example here, so I want you to see something. For an example, we have the center of, that is for the sphere. We have the radius from here to here, it's 9. And from this point to this point, it must be 9. But we have a portion here which is, let me say this is the height here, the height of the cone. From the apex, height of the cone. So I have the height of the cone. So, but there's this portion here that will be left out. Let's say if it is cut out, there will be that small portion which will be left out. So this portion here, we have to subtract out here. We have to subtract out to get this h here. So we know that according to the radius, when you have that, it's 9 centimeter, 9 centimeter. So it's 9 centimeter. So height of the cone. So if we take out that portion, we can get that total height. But I'm interested in this part from here to here. So what we're going to project, we'll project it. I hope you'll agree with me. So this is it reminds me of trigonometry. From here to here, the right angle triangle. I want to project this small right angle triangle because this we have a 90-degree. If we project here, I want you to agree with me. If we hit the tip of the sphere there, from this point to that point, the radius of the sphere is still the same. Yes. You take it slowly. So you'll agree with me that as much as you said here, this the radius keeps shading. So the radius from here is still the radius of what? Of the sphere. So the sphere, so even there's the radius. So which means here even to there is still what? It's still 9 degrees. So we can try and what we're trying to look for, we need to find the height, the maximum height. So this can help us to find just the small radius of the cone, the radius of the cone. So what we're going to do from here to here, you'll agree with me that when we minus this portion, we are minusing 9 from h. So we are minusing 9 from h. Take this line. So if we are looking for this just portion here, this height here, let me just say this height. Just this height for this right angle triangle, you'll agree with me that it is, we subtract it there, it will be 9 minus h. So we minus from h to get this portion here. So we know that this part, this blue flag, this part, it will be h minus 9. So that is the side of that right angle triangle. And therefore we can try and maybe work out in terms of h this right angle triangle. And here we know that we still have what? We still have 9. So we said it's the radius, so it's still 9. So from that right angle triangle, we can work it out because of space. Can I put text here? So I wanted to say here, let's give an example. We say here it's A, the color, use yellow. So let's say for an example here, let's just say this corner, it is A. And this tip here is B. And here we say this tip of the triangle, it is C. So it is C. So as much as we have right angle triangle, we can work out utilizing theorem of Pythagoras. So using theorem of Pythagoras. So using theorem of Pythagoras, which we know that is given by x squared plus y squared equals to r squared, right? So what we're going to do here, as we said, this is AB. So you can say AB squared plus the y side, which is AC squared. So let me use these alphabets that I chose then. So we'll say that it is AB squared plus AC squared. It's equals to, we'll say BC squared. So we substitute AB, which we know it is R squared plus AC is h minus 9 all squared. It is equals to, is it here? BC squared, it is 9 squared, is it here? Okay, so it is going to be BC squared. So we'll have 9 squared. The number 2, therefore, because we know that we need to know what is the maximum height of the cone that can be cut out from that sphere. So we can try and work out in terms of either R or in terms of H. So, but let's try and make, first of all, what is the formula for a cone? Formula for a cone. So in the formulas that they were given in the table, it's V equals to pi cone square, squared h, So it's pi r squared h. Pi r squared h. So it's for a cone. So 1 over 3, no? That 1 over 3. I see, because I know the sphere is 4 over 3. So that it's 1 over 3 pi r squared h. That is the volume of a cone. So we will want to determine the maximum height that can be cut out of this sphere. Therefore, now we're going to have r squared. Can we take out this bracket? What are we going to have? It's h squared minus, it's minus 18h. When you square 9, it's 18. It's 81. Therefore, it's equals to square 9. It's equals to 81. So let's work out the formula to be in terms of h. So we'll have r squared, which is going to be equals to, So let us work in terms of r. So when we take 18 to the other side, it's going to be 0. And then when we take h squared to the other side, it will be negative h squared. And when it comes to negative 18, it's going to be plus 18h. So at least it's in terms of h. So it's because we want to maximize. Now for a maximum volume of the cone, we know that we have to derivate what? To maximize, let's say, volume, or for, as we know, volume depends on height or the radius. So to maximum volume, we need to derivate, if you remember. Then for a maximum, we need to get what? We need to equate it equals to 0, to say. So, but yeah, that's where we're going. We're going to state that the volume of a cone is equals to. Now, in terms of h, it is pi. We said r is equals to what? It's negative h squared plus 18h multiplied by h. And it's all in all to the power of, okay, r squared was here, it's 5. So if it was square root of r, we're going to have square root of r squared. So we said r squared is equal to that. So yeah, that's correct. So therefore, before we even change the function, because you can use product rule when you don't multiply out. So let's multiply out. So I hope you see that h multiplies h, isn't it? So we're going to have 1 over 3 pi, and then negative what? Negative h to the power of 3. So h times h is negative h cubed, multiplied by 1 over 3 pi. So the second one, it is h times h. We know it's going to be h what? H squared. Therefore, multiply by 1 over 3 pi times 18. So it is pi over 18. It goes how many times? Negative 1 over 3 pi h cubed. And I'm busy saying 6. So because 3 divided by 18, it's 18 divided by 3 is 6. 6 pi h squared. So I hope we agree then. Therefore, for a maximum height, we know that first of all, we're going to change the volume in terms of height. So we're going to say dv over dh is going to be equals to. So 3 times 1 over 3, we know is going to be negative pi h squared. So 1 over 3 times 3, it is 1 times pi, subtract 1 from h to the power of 3. Therefore, plus 6 times 2. So we have 12 pi. Subtract 1 from h there. So we have that. So we know for a maximum volume, because of maximum height, we need to equate the equation to 0. So we know, I always give an example, or maybe I give an example with a graph. We know at the maximum, we have m is equals to 0. So dv over h for that slope is equals to 0. So we'll state that 0 now, it is equals to, okay, let me say for a maximum volume or height. For maximum volume, dv over dh is equals to 0. So we'll have 0 is equals to negative pi h squared plus 12 pi h. So we have to solve for h. So what we're going to do here, I think we are going to take out the common factor, but let's first divide by pi. I hope you'll agree. To get rid of pi. I hope you see that. So or negative pi. I don't know if you see that. I don't want to skip, but I want to write things in order. So divide 0 by negative pi, still 0. And we need to take out the common factor of h in the meantime. So we'll be left with h. We have divided by negative pi, we'll be left with negative 12. And then we have divided by h2. So we're left with negative 12. So we know that h is going to be equals to 0, isn't it? Or h is equals to 12. So we know even before you start derivating for the second time, the maximum height already we have it, which is 12. We cannot have 0 as a height. I hope you'll agree with me. Because when you cut out of a sphere, we cannot have a 0 height. So even if you derivate the function for the second time, there's no need. So we know that therefore the max height is equals to 12. So if you wanted to prove that, you're going to derivate the function twice and substitute the value of h into the second derivative. So you're going to try and say d squared v over th. It will be equals to what? The second derivative of this function. It was going to be negative pi, negative 2, right? Negative 2 pi h. And then we're going to have positive 12 pi in terms of h. Derivate in terms of h. So therefore, in the second derivative, we're going to substitute 12, which is the height there, the plus 12. Then there's this pi. Then pi. So you're getting a negative value, isn't it? You must get a negative value. Oh, this is negative 24. This is 12. So it was going to be negative 12 pi. So it's negative 12 pi, isn't it? So a negative value means what? So it reaches, that's the maximum. So it's true, this is the maximum. This is the maximum height that can be cut out of that sphere. So if you want to prove, so that's how you can do it. Yeah. So it was an interesting one when